friends, we are going into class 5 of module 5, and in this class we are going to discuss a problem related to transmission loss as a function of generation, or we can also call this one as economic load dispatch problem including the transmission losses. Okay, so we are going into the problem. For a simple two plant system, assume the loss formula coefficients, in 1 per megawatt units given by BMN value for each M and N values. Okay, here you can see if M takes the value 1 and N takes the value 1, then BMN value, that means B11 will be equal to 0.0015. Similarly, B12 or B21 will be equal to B12 equal to B21 will be equal to minus 0.0005. Okay, and the last one B22, loss coefficient B22 will be equal to 0.0025. And also assume that dF1 by dP1 is equal to the equation, and dF2 by dP2 is equal to this much. So this dF1 and dP1 is incremental cost production equation. You can study, we have studied it in the last classes. The objective to determine the operating schedule corresponding to lambda is equal to 2.6. So they have given a definite value for lambda. We cannot change the value of lambda. So such variations are not possible. So the iteration as a complete flow chart which we have studied, it is not possible here. So I'll be just showing you the flow chart, and from word to word we have to do, I'll be just explaining. Okay, so this problem actually asks to find the optimal solution or operating schedule, and the lambda value is fixed value. Lambda is a fixed value. We cannot change the lambda. So you can see where the lambda value is being changing according to the value change in the delta P. So that is not to be done. We don't need to make any variations in the lambda. Lambda value is a constant. So actually we are doing the problem till here only. Okay, so here this problem is only done till here. It is only needed to be done here till here. Why? Because the lambda value is a constant. We cannot change the value of lambda. Okay, so let's do this problem. Let's start with how to solve this problem. Just go through the flow chart. Start with reading all these values given in the question. Okay, then we have to assume a suitable value that is already given in the question, lambda value. Okay, and then what we have to do? Determine Pn corresponding to incremental cost of production, equal incremental cost of production. So equal incremental cost of production equation can be used to find out the Pn value, which was done in the previous problem. Okay, so let's do that one first. Then we are going for the first iteration. Then solve for the generation including the losses. Okay, this using this equation we can solve this. Then we have to check whether it is not going, whether inside the limit, is it inside the limit or crossing any constraint. But in this problem no constraint is given, so we can go for the next buses. If all the buses are done, we have to check for whether the iteration is being converging, whether the iteration values, the difference between the two iteration values are converging or not. Okay, if it is converging, we can finish off the problem by calculating the loss in the circuit. Okay, let us do this. So solution. So problem is just they have given the M value, the loss coefficients are given, as well as the equal incremental, the incremental cost curve is also given. Okay, these two things are being given in the question and asked to find for lambda is equal to, operating schedule for lambda is equal to 2.6. Let's move on to the problem solution. So first we have to select, we have already read the values of F11, okay, F22, F1, F2. These values are already found. Then lambda value is already obtained, 2.6. Now we can start doing the problem. So find the first generation. Now we have to do the first one. First step is calculate the generation according to the equal incremental cost of production. Okay, equal incremental cost of production, that was our first step. So we are doing it. We know that lambda is equal to dF1 by dP1 is equal to dF2 by dP2. So substitute, instead of dF1 by dP1, we can substitute as lambda. So see here in this question, you are saying dF1 by dP1. Instead of this, put lambda. Okay, in the second equation also put as lambda. Then you can solve what is P1 and P2. Because lambda value is already 2.6. From this you can find out what is the P1 and P2. This is according to the equal incremental cost equation. And here we are not considering any transmission losses. We are not considering any transmission losses here. So this is according to the equal incremental cost production. Okay, now next we are moving into the first iteration. We are moving into the iteration steps. Let's put for k is equal to 0. We are going for k is equal to 0. So what we are doing is we are going to find the generation including the losses using the new equation. Okay, we are substituting all the values corresponding to, for P1 we are finding, and for P2 also we are going to find. Okay, and we will be getting this equation as P1. While solving, we will be getting P1 equation like this and P2 equation like this, where you can see that P1 equation, it is actually depending upon some P2 value, and P2 value is actually depending upon some P1 value. Now these two values can be substituted from the first equation according to the equal incremental cost of production. P1 and P2 as calculated from the equal incremental cost of production can be substituted here to find the 0th iteration value. Okay, so substitute for P1 and P2 from the first equation. So for 0th iteration, that is k is equal to 0, just substitute that value which we have obtained from the equal incremental cost of production. From that you can find P1 0 and P2 0. Now what we have to do? You just go through whether the power is being converging or not. So for that we have to do the next iteration, that is for k is equal to 1. For k is equal to 1, I will be representing it as P11. The only difference we are doing is, we are, instead of substituting for the power, we are substituting it as P10 value. See here you can see the P10 value and P20 value. This values has to be substituted for the next iteration. Now we got the new value of power, that is 41.68 and 52.53. Now just compare these two values. You can see this one is P1 and this one is P2. Just go through whether there is any much variation between P1 1 and P1 0. That is mentioned as in the flowchart P1K or PIK minus K plus 1 and K. Okay, whether it is converging or not, whether it is less than a particular very small value epsilon. Okay, let's go through 41 point and 49, which means it is having a large difference between them. 52 and 54, it is a large difference. So we have to make next iteration. Why? Because it has not converged. So we are going for the next iteration for as delta P. That means the change in the iteration values are high. So we are going for the next iteration. So substitute k is equal to 2. For k is equal to 2, we have to take the iteration values of the previous one. That is for k is equal to 1. So we have to use this power equation. We have to use this this power equation, power value for the second iteration. For second iteration, you just substitute P1 2 is equal to, instead of here you can substitute as the first iteration value. First iteration values, this one and this one. Okay, so you will be getting the second iteration value. It is just a repetition. So after that we will be getting the answers like this. Now again check whether there is any difference between the previous iteration and this iteration, that is k is equal to 1 and k is equal to 2. So here you can see for k is equal to, just compare, for k is equal to 1, 41.38, and for second iteration 41.38. It is almost near, coming near to the iteration values are coming nearer. Next one is P2, P22 and P21, 52 point something, 52 point something, which means now it is almost converging. Okay, let's do one more thing. One more time we can do the calculation. Okay, so after doing one more calculation, that means the third iteration, the answers are 41.37 megawatt and 52.50 megawatt. Compare with the previous one, you can see 41.38 and 41.37 means almost it is near. Okay, and this one has already converged, that is 52 and 52.50 and 52.50. So by this we can stop at this point. Now we have already found out the generation, and using the generation now we can calculate the loss in the circuit. So in this system. So PL is equal to, what is the equation for PL? PL is equal to sigma m n PM BMN. Okay, so I am substituting the values for each of them. First one, m is equal to 1, n is equal to 1. So P1 B11 P1. Next one is P1 m is equal to 1 and n is equal to 2. So then b1 to p2. Or you can also write like a matrix form, and you can multiply and add all those things and write this equation. Now substitute all the values for the, this is our generated value, now new generated value. Now using this you can substitute the values and find out what is the answer for this loss. So from this we can obtain the loss value as 7.28 megawatt. And now we can decide what is the load. The load is equal to, what is the load? It is being supplying delta Pg minus PL. What is delta Pg? Means the total generation done by the two generators. The total generation by the two generators is 41.37 plus 52.50. By adding both, we will be getting 93.87 minus the transmission losses which we obtain now is the total load it is being supplying. So this is the load value it is being supplying. So this problem gives the solution till here. And if you want the further how to make a operating schedule for the corresponding values of given BM and everything, you can go through that textbook portion where they are describing a long iterative process how to make the operating schedule. It is being explained over there. So till here is being explained in this problem. So thank you everyone for listening. Hope you understood. Study well.